Today we are going to be learning about the 3 laws of thermodynamics. Thermodynamics is the branch of physics that studies the flow of heat and work and their effects on energy. The first law of thermodynamics states that the energy of the universe is constant. It provides a way to keep track of energy as it changes form and gives no information about why a particular process occurs in a given direction. Your body is an example of the first law. In order for your body to move and do work and maintain its normal core body temperature, you must add chemical energy in the form of food. No energy and alternately means no work or heat produced. The second law of thermodynamics states that for any spontaneous process, there is always an increase in entropy of the universe. Entropy, S, is a thermodynamic function that describes the number of arrangements, positions, and/or energy levels available to a system existing in a given state. Nature spontaneously proceeds towards states that have the highest probability of occurring. An example of this law would be your house on a hot day. The heat from the outside will move into the cool house inside. To move the heat outside, where it is hotter, you have to use an air conditioning unit, which uses energy to push the heat out. There's equations that come with the second law. So the second law, using entropy, the thermodynamics can predict the direction of which a process will occur spontaneously. So your first equation is S universe, S system, and S surrounding. For a spontaneous process, the delta S universe must be positive, where delta S surrounding and delta S system represent the charges and entropy that occur in the system and surroundings respectively. The other equation that goes with the second law is delta S surround is determined by heat. So you have delta S universe equals negative delta heat divided by temperature. Delta S surrounding is positive for an exothermic process. Delta H is negative in this. Delta S surrounding depends inversely on the temperature. Finally, the third law. The third law states the entropy of a perfect crystal at 0 Kelvin is 0. Because entropy is a state function of the system, it is not pathway dependent. The entropy change for a given chemical reaction can be calculated by taking the difference between standard entropy values and of products and those of the reactants. Using this equation, you can do exactly what was stated up here. So delta S reaction equals the sum of S products and the sum of S reactants. So it's always products minus reactants. Those are the 3 laws of thermodynamics.